So just a quick introduction from myself, and I'll let this panel discussion begin. So welcome to everybody. This is the second of the Data Center Leadership webinars hosted by Data Centers Ireland. I would like to thank the panelists for giving up their time for this discussion. Can I just say to any attendees who may wish to raise a question, these can be submitted through the chat room, which is a moderated chat box, and we will send them to the panelists at the end of this discussion so they can answer them directly. So with that, and without further ado, let me hand over to our moderator of today, which is Dave McCauley, CEO and founder of BitPower Energy Consulting. And Dave, over to you. Thank you very much.
Thank you, Hugh. Good morning, everybody. This session is about energy and data centres in Ireland. It's a 90-minute session. We have 4 panellists who I'll introduce in a minute. The subject is quite close to my heart. It's something I spend a lot of time looking at. Just last week, the Chinese social media giant TikTok announced they were going to build a huge data centre in Ireland, 500 million euros to be opened by 2022. This just adds to the list of data centres that we've been tracking over the past number of years. Ireland has huge success in the data industry with Microsoft, Amazon, Google and Facebook, plus a number of other smaller operators actually established in Ireland and building quite a European base. The industry has probably been 60 years here in Ireland, although it seems like an overnight success. Most of the companies that I speak to say they've had operations here and that data centers are just an efficient manner of delivering the service that they've been doing. Obviously, we've seen huge growth in demand, particularly highlighted with the COVID time. We see a huge amount of video conferencing. We would normally be doing this session in a big room with 200 people. So you can see we're all using different apps. We're all watching Netflix. So the internet has become quite a thing. Ireland's had huge success mainly due to its ease of doing business, its location between Europe and the US. Ease of doing business is one of the things that they talk about. Tax is obviously another. We see about 60 data centres in Ireland. That's going to double in the next 5 or 6 years. The power demand is around 700 megawatts. That's going to increase. Dublin is becoming constrained for power, like any other data centre hub that we see, North Virginia, Amsterdam, etc. And in the back of all this, we have a huge change in the energy industry, with a lot of new wind, a lot of new resources coming on stream. So there's a number of challenges. You've got a moving energy system and a moving data centre system. And can we bring the two together? And I think the panel that we have today are in a great position to speak about this. I have 4 distinguished panelists, and I'm going to introduce them now, and then we'll get into a Q&A session. So first off, I'm going to introduce Dr. Lisa Ryan, Assistant Professor of Energy Economics at UCD. Lisa lectures in UCD and leads energy economics research at the UCD Energy Institute. She's a board member of the Sustainable Energy Authority of Ireland, a former employer of mine. She previously worked with the IEA and she has extensive industry experience. Lisa and her team at UCD help convert data into policy direction for government. So thanks for joining us from your holidays, Lisa. You're very welcome.
Most welcome. Thanks.
Great stuff. Next up, we have, I think it's Doctor as well, Liam Ryan, Chief Innovation and Planning Officer at AirGrid Group. Liam has had many leading roles with AirGrid, including heading ISEM, engineering and maintenance, market operations, operation planning, program management. His background includes innovation with HP and some consultancy work. He knows how the electricity system works. He's probably forgotten more than I'll ever know. So you're very welcome, Liam.
Good to hear. Thank you.
Okay. Next up, we have Damien Gaynor, Chief Marketing Officer from Echelon Data Centres. 20 years experience in the telecoms and IT industry, number of senior roles. He's currently working on the development of a number of facilities with Echelon in and around the Dublin and the East Coast area in Ireland. I think he knows his stuff. I had a chance to pick his brain for about a day a few months back and ask him all the hard questions. And he's a great communicator and really knows his stuff. So I think he'll be a valuable contributor to this session. So welcome, Damien.
Thank you.
And last but not least, we have Dermot McCardle, Business Markets Manager at ESB. Dermot says he's been with the energy industry for 30 years. So Dermot, you've seen huge change. You manage ESB's business solutions for large energy users in the Republic and the north of Ireland. For anyone who doesn't know, ESB supply electricity, gas and telecom. He's worked in finance, commercial, generation, supply with ESB, every bit of it. He led the ESB e-cars initiative. And more recently, he's been shaping the business vision of ESB's strategy into the future and seeing data centres as a key area of growth for the energy sector. Welcome back to the past, David.
Thanks, David.
Great stuff. So thanks, you all. So look, I suppose to get into it, to talk about data centres and energy, I suppose the first thing to cover is what is the energy picture for data centres. As I mentioned earlier, we see about 700 megawatts. We track this every quarter, excuse me, across 60 odd data centres. Half of those data centres are hyperscale. For anybody who doesn't know, hyperscales is Google, Microsoft, Amazon, Facebook, and would include Apple and some others. The likes of TikTok and these guys probably fall into some of those hyperscales realistically. We're seeing a huge growth. And I suppose the question for you guys is, where does that fit? And I might come to Lisa first. In terms of the overall energy system in Ireland, 700 megawatts, is that a lot? Is it a small bit? Does it count? Should we be looking at transport and heat, or where does it fit? Maybe you can give us some background on your system.
Yeah, no problem. I'll be glad to start. I should say that although I'm in the School of Economics in UCD, I'm part of a multidisciplinary institute in UCD, the Energy Institute in UCD. So I have to lean very heavily on my colleagues in electrical engineering for a lot of the more technical side of our work. And definitely in this area, economics and electrical engineering go hand in hand together. You can't really do one without the other, that's for sure. I think there's no doubt that we have changes coming our way up to 2030. We can see from both national and European obligations and regulations and requirements that, broadly what we're looking at is a reduction in greenhouse gas emissions more than we've ever achieved before. Switching our electricity system over to renewables as far as possible, to 70% renewable electricity by 2030, while at the same time electrifying heat and transport. And then at the same time, we have all these data centers coming online that are going to really increase demand for electricity. So while we shouldn't neglect other forms of heat and transport, I think electricity is really growing in importance. And I think I was delighted to participate in this webinar, because I think data centers, it's something that you hear a lot about in the press. And I think there's a lot of discussion, and people aren't sure, are data centers going to help with this whole system, or are they going to put a burden on it? And is it going to make it more difficult to achieve all these different obligations? So that's kind of the overall context that I would say. I don't know, I might hand over to my colleagues. EirGrid have done some very nice scenarios in terms of where they see the future 2030, look how it looks at, and I wouldn't like to steal their thunder, so to speak, since those scenarios come from EirGrid that a lot of us are using actually in our modelling of the future.
Yeah, so I'll just pick up a little bit. Just like we've been on this journey for quite a while. So if I just step back a little bit, is that about in Dublin, excluding the data centres, our peak demand is about 1,500 MVA is what we actually need to meet the demand. And since 2014, we have seen about 2,600 MVA of applications seeking to connect. That's between connected and seeking capacity in the kind of mainly in the Dublin region. And that in itself is much higher than the peak demands that we actually have for all the other types of generation, or all the other types of demand in the region. But we are planning the system with that. The challenge that we actually have is that the data centres at the moment are probably only using a fraction of that capacity that they have advised us that they actually need. And when we look out to 2030 and we have engagements with all the data centers and looking at their profiles and what they actually need to do. We're looking probably at a 50% demand growth on the islands during that period, in Ireland during that period in time. And of that, roughly 29% of the demand in 2030 will come from the data center sector. So it's a significant demand on the system. But we are now trying to plan the system to have that transition, knowing this is the demand that we actually need to meet. And one of the challenges that we have is looking at where do we prioritize. So if we have more clearer figures around what we need from the data center, at their growth profiles, that allows us to move forward in relation to. So we're planning for those demands, and we're trying to actually figure out how we transition through that item to those items. And some we put in mitigation measures in the middle, which is the flexible demand items around that. So I can talk further on it, but I'll give my colleagues some chance to talk as well.
I think we'll come back to the flexibility question. They're amazing numbers. The 2,600 MVA increase in demand, 50% increase, the 29% by 2030. I think you mentioned. Is that like based on 100% utilization of all that power, or is that because you guys got a plan for the worst case? That's
probably our median scenario. Looking at a median growth potential is what we're actually looking at. That, but again, we are looking at significant numbers in and around that. And again, one of the challenges that we have is that a lot is located in and around the Dublin region, and that by itself brings challenges about making sure that we actually have the supply coming into Dublin, because we have supply within the Dublin region, which is the generators that are there, which is the likes of the Huntsdown unit or Dublin Bay Power as examples. And then we also actually have the circuits that bring power into Dublin. And one of the key challenges that we have is getting renewables from maybe the west of Ireland over into the Dublin region. And we know that offshore is going to be part of what we're going to be doing into the future. And the East Coast injection of offshore should help with some of this. But again, that's 2026 maybe time frame before we start seeing some of that coming really on board. It might be earlier, but being realistic, that's what we actually see.
Excellent, Liam. We'll come back to some of those points that you raised, but I want to bring in Damien just to. So Damien, I started looking at data centers 15 years ago. They were like 2 megawatts. Now they're 20 megawatt buildings. Can you give us a sense of why that is, or what's going on there? Why are they so concentrated, big buildings?
Okay, so when everything started with data centers, it came from telecommunications networking. So you had peering points and internet exchange points, and essentially they were used as houses for carriers to terminate their equipment and terminate their circuits. So it started out, I suppose, more in terms of kind of transmission, and they were all telehouses, which is where that name came from. But what we've seen is an evolution in the demand from consumers for how we consume data. So, we're using online services now. I mean, again, it's grown from 2 megawatts up to 20. That's now considered metro. A hyperscaler will look at 100 megawatts plus. We're hearing now in certain sites they're looking at 250 megawatt sites. This has a lot to do with the amount of data that we're all consuming. If you look at the growth in data centers, looking at annual growth rates of about 8% and above, depending on the area. But just, I think maybe there's a couple of stats that make a bit more sense of it. In the COVID period, cloud-based services grew like almost exponentially. I think Microsoft Teams grew by, if we go back to June, by 894%. Zoom grew by 694%. And that's on top of, I suppose, year-on-year cloud growth, So businesses using the cloud to host their data, host their websites, etc. You're looking at Microsoft 27% year-on-year growth, Google 52%, AWS 33%, and that's only going to grow. We haven't even factored in some of the new AI, machine learning solutions. Autonomous driving is going to drive that up massively. I mean, 45 gigs per car per day. So when we factor in the likes of 5G, I think we've kind of crossed the Rubicon in terms of we're not going to move back from the digital generation that we've become. So really what we need to look at, responsibly, how can we grow, but grow in a way that's harmonious, that's green, and that allows us to work in collaboration with the TSOs and DSOs so that it all works and nothing falls over.
Excellent. Brilliant. So it's continuing to grow. Is it replacing kind of the inefficient servers in offices, or is that phase gone now? Have we kind of absorbed all the inefficient stuff and now we're going into that growth piece?
There are still lots and lots. I think you'll find that most companies still aren't on the cloud completely. Okay. So if you talk to the cloud providers, they will say that growth rates are going to still keep going like this for the foreseeable future. Most people have moved away from having bare metal in the offices. So yeah, I think those days are just about gone. But again, the next phase of once we get 5G there, I mean, you won't be able to do your compute on your handset. It will all be, all your compute will be done at the edge or in data centers. So yeah, we're moving towards a more distributed and more centralized system at the same time, which is an interesting balancing act.
Okay, because the International Energy Agency, I think it was last year, put out an interesting piece on digitalization, and it talked about the benefits of digitalization to different sectors. But interestingly, they talked about, I think they gave a number of 200 terawatt hours or something for the total electricity use in servers across the world. And then they said that had increased by about 3% in over 7 years, which seemed tiny to me. And I did a follow-up graph which showed a reduction in the amount of energy used in tiny data centers in your office. Mm-hmm. So there was an interesting trend to see, but I presume I'm thinking it's got to be absorbed.
If we look historically at, say, the old telehouses and you were looking at the actual racks would consume about 3 kilowatts. So telecoms would be around 3 kilowatt racks. I think the average among, say, some of the web scalers and cloud companies, it's now up at about 8.
Yeah. There
are certainly applications we've seen that are up at 12 and 15 kilowatts per rack. And if you look at high-powered computing, I've heard numbers of 230 kilowatts and above per rack. And the density of those, I mean, look, if you look at the semiconductor industry and you look at, there are now chipsets, wafers that will consume 9 kilowatts just for one wafer, and they will be using more than one. So we've kind of hit a bit of a hockey stick in terms of the curve. And it draws into question lots of things about how efficient data centers should be, how they should be designed, and I'm sure we're going to cover lots of that.
Excellent. Perfect. Dermot, I need to come over to you because you kind of sat silently there. We didn't give you a chance yet. I heard you speak before, Dermot, about the history of DSB, and you've done a lot of work, if I recall, on looking back to the formation of the state and DSB and those. Is this unprecedented? I mean, like, that was a huge change for the system, for how we used to use coal and logs, and then there was this huge transition into electricity. Is this a whole new paradigm shift, or is this just something along the path that we see every decade or so?
If you look back over the last history of electricity in this country since the foundation of the state, we've gone through a number of these big changes. So it's not unprecedented in that sense. And I think if you look back, particularly over the last 20 years, maybe from the mid-1990s onwards, we've had strong economic growth within the country. And there's always been, well, certainly there used to be a strong correlation between economic growth and energy demand. I think if you were to pick out an element of this and say kind of what would make this different as opposed to maybe kind of, largely unprecedented, is that it's very much concentrated in one sector. So, if you break the market down, there's roughly three elements to the market. You'd have your residential demand, you'd have your small, medium enterprises, and then you'd have what we call large energy users. And what we're seeing going forward is that, basically on the, the first two of those, the residential demand, the small, medium enterprises, there's some growth within there, but it's, it's largely flat, moving towards some level of growth. And where we're seeing the growth kind of coming forward over the next, 10 years or so is in the large energy user segment. So the fact of its concentration kind of, is different because typically in that segment of the market, it's baseload demand, so kind of it's demand that's 24/7, and kind of what you're seeing in data centers is, exactly that. So a data center runs 24/7. So it's a different kind of demand. It's different in that it's concentrated in one sector of the market, but it's not different in the sense that kind of we have had periods of rapid growth in the economy before, and that rapid growth in the economy has traditionally led to, rapid growth in terms of energy demand. So I think kind of in one sense, no, we've been through this before. And then if you look at it through a different lens or a different perspective, it absolutely is different because of the concentration in one particular segment. And one area of that segment, data centers, I think Liam mentioned it, are a very big, component of the future energy growth demands over the next 10 years, so albeit it'll be in the LEU sector, and we'll see it in other areas in there as well, like, big pharma, semiconductor manufacturing, all of that. But data centers, very specifically, as a single segment in that sector will drive a lot of that energy demand. So in that sense, it is very different. So, but, as I say, kind of we've been through these changes before.
Okay. So it's a big investment is required now in new overhead lines or substations, or is the challenge around getting that infrastructure, or is it about getting the power? Maybe Liam,
the infrastructure is one element of it. I mean, kind of, as Damien mentioned there, kind of, the demand that's been driven through data centers, you're talking kind of 9 kilowatts for one wafer. That's substantial, and that's one wafer 24/7. So that drives a lot of kind of, infrastructural reinforcement that would be required on the transmission system, potentially, it's certainly going to have the distribution system as well. So that drives costs into the system, no doubt, and they will have to be shared out, across, the general kind of energy demand. So, it does have complications associated with it, but it has benefits as well because, kind of the more energy you push through the system, if you look at kind of the overall cost of the system as a kind of your numerator and your denominator, you kind of if you have more energy going through the system, you have the chance to spread that the overall cost of the system over a greater number of units, kind of running through it and potentially kind of have a positive effect on the overall energy cost. So it has complications, but it has potential benefits as well.
Okay, Liam, I know that a number of the data center developers they tend to build a substation now beside it, so they seem to be absorbing a lot of cost for upgrading the network. Is that how you see it, or is there a wider cost?
Yeah, no, there is wider cost. So I think it's for a large energy user demand customer connecting on to the transmission system. The current pricing policy around it is that they would generally pay 50% of the shallow connection cost. That's the cost of connecting their site onto the existing transmission system. And that may mean a substation being built for their own facilities they're actually looking at. And again, if we look at that in the future, then we can connect into those. That's an overall good from what we're actually doing. But then there's also the other kind of deep reinforcements, the reinforcements that are further back in the network, which are needed to bring the power from the generation sites to those large energy users. And therefore, those costs, as Dermot actually said, are then socialized across all the users of the system through what's called a transmission use of system charge or a distribution system use of charge. And the more customers that you actually have and the more energy they use, then the overall price is kind of smeared differently around that. So, for example, if you have 100 MVA data center with a 70% load factor, they're paying probably in and around 7 million use of system charge per year, and that goes towards the maintenance and upgrade and building new infrastructure on the system. So there is some benefits around it, but in essence, it's a case of that the key challenge is getting the power to those locations in and around the Dublin region in particular.
Excellent. A question that we constantly get when we do these kind of seminars is, why don't we just move all the data centers to where the wind is, for instance? Damien, I see spiking up there. Is it practical? We're seeing a bit of a spread. Damien himself, actually, with Echelon, they've planned something in Arklow, which is like 50 kilometers south. I think some of the hyperscales they used to talk about a 45-kilometer zone, and they wouldn't go outside of that. They seem to be stretching to maybe 100 kilometers. We're seeing a development up near Drogheda. Again, that's stretching it a little bit more. It's mostly East Coast. Damien, have you a sense of why that is?
So latency is possibly an oversimplification of the requirements. Essentially, there are kind of three elements that are looked at when you look at a data center. So you've got to have the scale for whatever data center you're going to build. You will need reasonably good latency. Obviously, you need to have good connections back to other sites. You will also need power. But then the other part of that is generally these things work in nodes. So you have more than one node on a network for, stability, everything else. Essentially, you're looking at availability zones. So to say that one region can't be used or another region is better isn't typically the case. So look, you're seeing throughout Europe, so all of the flaps areas, as they're called in data center world, so Frankfurt, London, Amsterdam, Paris, Dublin, you're seeing that the transmission networks are constrained because of the very high demands that certainly our industry put on them. I think it's kind of incumbent upon us to look at, okay, how does this work into the future? We can see demand is going to go up. So our view certainly in Echelon is that regionalization is something that we support. We want to provide the infrastructure for the occupiers so that they can have multiple nodes outside of Dublin. It will hopefully help take a little bit of the constraints off the network, allow people, to move from kind of a centralized demand to a more distributed demand and move the consumption closer to the generation. I mean, look, I don't want to do sales pitches. Arklow, obviously, there's aggregated maybe a gigawatt of renewable energy from the Arklow wind bank to the various solar providers. So it makes sense, I think, within the industry to move slightly more regionally. It will help, obviously. All of this is done in collaboration. We certainly, data centers work very, very closely with EirGrid and ESB, Dermot and Liam, colleagues of mine quite well. So, we need to move this together, and to be sustainable, we need to move more regionally. And I do think that a lot of the hyperscalers and the other connecting parts in terms of networks, etc., are starting to be built. And there is an understanding in my discussions with various occupiers. Yeah, we have to start moving slightly out of the central cities.
Okay, you've given me a nice segue into the renewable piece. Lisa, maybe I'll pick on you on this one. Another question we get a lot is, these data centers are using up all the renewable energy. They're all that wind. They're using it all up, and we're going to miss our targets because the data centers. I get these confused arguments. Who pays for all this wind energy that we're deploying? There seem to be huge plans. Who's going to build it?
Okay, well, I think just one last point on the regionalisation I was going to say was that I think it's quite an interesting question in terms of public acceptability and behaviour. How will data centres be perceived if they're the regions And how will that make planning for wind farms, for example, more acceptable? I think it's a really interesting question. So I'm just going back a step back I'll come to your other question. And I've been thinking, with the planning debacle for Apple, for example, if there had been, local wind, would it have made wind more acceptable? It's just a question I'm putting out there. I think it's kind of interesting to start thinking about. And the other point, I suppose, is the configuration of data centers on the East Coast. If in 2030 we have a lot more offshore wind on the West Coast, how will that change as well, the regionalisation? But the transmission, I understand, might be complicated. I'll leave others to look at that. But I think there's a lot of interesting questions around regionalisation, and even in terms of employment and direct benefits to communities and indirect benefits in the construction of them. I could imagine that the sustainability of data centres might be more positive if they were located outside the Dublin region, for sure. But coming to the renewables and how the markets are working, there's no doubt that we have to change the energy market. And this has been ongoing, even with Ireland moving to the ISOM from our own single electricity market in Ireland. And basically what's happening with the amount of renewables on the system, we're moving from a system that had high variable costs when we had fuel costs to now one that has higher fixed costs and very few variable costs. And this is because obviously if you have wind and solar in the future, then you have very low fuel costs. And this is changing, of course, then the market. There'll be times that on a windy day, we'll have prices dropping to zero, going negative in some places where we're having to spill wind, curtail wind, because there's too much of it on the system. Whereas in other days, we still need to be able to either have storage, or we need to lean on different kinds of probably gas in the future mainly, that has high variable costs. So this is very difficult to manage. And I suppose the question then, we'll come to flexibility in a moment, I know, but how do data centres play a role in this? Right now, at least this is how we model data centres, correct me if I'm wrong, they have a very kind of constant base load that is increasing every year with the number that's coming on the system. So that's not really in tune with a kind of a more flexible system with a lot of wind on the system. But right now, I suppose what's happening is we have some days where you have the price dropping to zero, and other days where it's really reaching peaks. And who should pay for it? Well, renewables have been paid for and developed by private developers with subsidies, of course, from Ireland, from the government. But those subsidies are paid for by every electricity consumer in their bills and the public service obligation. You could argue that it has been heavily subsidised by consumers. Not as extreme as the other countries where they've put it all on residential. I think in Ireland we have spread it a little bit more between industrial and residential customers. But overall, it's considered a public good. It was something that needed to be subsidised to get it off the ground. But we got in a little bit later in Ireland. You could consider compared with, say, Germany, where they subsidise a lot heavier because they went in early. And Ireland has benefited. And because we came a little bit later on wind, we haven't had to pay. We've had quite good value for renewables so far. The question is now, as the prices come down, offshore wind, the price is dropping and dropping of the technology every year. Will we need to subsidise it? Or will this be commercial on its own? And the auctions that are coming online are really going to show us in terms of what price will there be for renewables and how much will subsidy be required or not. But it's still a little bit unsure, I think, how that price is developing. But in the meantime, I suppose, going back to my original point, the market needs to be redesigned to pay for, to incentivize other services apart from energy, because when we don't have any wind, we need to have some storage, we need to incentivize reduced demand. And while we have had the DS3 program operating the last few years, and this has changed, I think we still need to do a lot more, not just in Ireland, but in the European electricity market. There's a lot of work going on and seeing how can we rearrange the market to provide incentives that will facilitate higher shares of renewables.
Excellent. Liam, this idea that all this wind is, I understand, is what's called non-synchronous, so it causes the system to kind of blip up and down and puts it at risk of failure, etc.
Yeah, I think one of the things is that I think we're very fortunate in Ireland that we have such a huge scale of wind, a huge capacity of wind on the system, and I think it's something that we need to fully exploit and utilise for the benefit of Ireland Inc. And that's one of the key things that we definitely need to do. And what we're actually seeing at the moment is that we have a very good handle on what wind can do. So at the moment, we're able to operate the power system with 65% instantaneous energy being coming from wind and renewables. And that's the first in the world that nobody else can actually do. And I think more recently, which has just recently been announced, that for onshore wind, we are the number one in Europe in relation to the amount of renewables that we have on the system. And we'll continue to go in that vein. So we have had a program, as Lisa has actually said, which is the DS3 program, which is really making sure that our power system is stable. And we are looking at how the market needs to change over the next number of years. And some of the dimensions that need to factor in on that is the energy market itself. So what is that going to evolve like? Because Europe have mainly been driving an energy which is more to utilize the interconnectors and have the max utilization of interconnectors rather than looking at how renewables are being integrated, and some of the clean energy package and Green Deal is going to change some of the items around that. But in essence, we see that by 2030, we will be pushing and operating the power system. Our ambition is to operate the power system with up to 95% instantaneous wind penetration, which will push us to 70% average wind or renewable on the system, not just wind, solar, and other types. So in essence, that's going to be a journey that we're going to have to go on. And as we actually go on the journey and as we transition across to it, there will be some key decisions that we will have to make in the industry around when we invest and when and where we should invest in the time scale that we're actually looking at. One of the items is definitely going to be the market. We actually envisage that as we start to get more and more renewables on the system, your price becomes more variable. So at times, as Lisa actually said, you'll actually have very high prices, and in other times you'll have very low prices or negative prices actually occurring on the system, tending towards zero roughly by 2030 or beyond. And then the question comes, well, where does the investment signals come from? So if the demand still keeps on growing, but if I'm actually an energy producer and I see my price in the energy market is almost zero, then that isn't the incentive to invest. So therefore, it's other services that we need to actually make sure that we are correctly incentivizing those. And we see the likes of inertia and fast frequency response and other services that you would normally just get from conventional generators because they were just there. And we're now saying, well, demand needs to play its part in providing those services.
Okay. I'll come back a little bit more on flexibility, Liam. That's some interesting points. But before we wrap up on the greening piece, maybe Dermot, just back to what Liam said, there's some ideas there around how the large energy users interact with the system. Have you seen a change? Have you guys developed different models? I mean, it seemed to be historically a one-way situation where you just bought kilowatt hours.
Yeah, it's certainly moving in a more of a two-way dynamic. Like as I say, if you went back, you're alluding to it there yourself, it was very much kind of one-way traffic in terms of, the system was kept in balance by EirGrid, or National Grid as it would have been known kind of a long time ago, just by simply matching generation to demand. I think what we're seeing now is a much more complex environment. And the guys, Lisa and Liam, have alluded to the technical complexity with the market and having intermittent generation on the system. That also leads its way to the commercial realities of the market as well. So if you look at it from the perspective of a supplier and a customer, the relationship there, what a customer will want, so a data center or any other large energy user, is price certainty. If an energy cost is a significant component of their cost base, they don't want to be exposed to the volatility of the wholesale energy markets. And there's always been a level of volatility. When STEM came in 2007, there was volatility on the half-hour pricing in the markets, but it was largely driven by movement, say, in gas prices. So as gas moved up or down, the wholesale energy costs moved up and down, and that level of, volatility was absorbed by the suppliers who kind of, took that on board and provided hedging products effectively retail products out to the end user and say, we can give you a level of price certainty for that. The other challenge that's coming to the fore now is around kind of the intermittent generation, that is, essentially renewable energy and wind. Wind is very, very hard to predict. Even a day ahead, wind is very, very difficult to predict. And if the wind doesn't turn up, the data centers don't go offline. The data centers, other large energy users, they still need energy input. So something has to step into breach for that, and that's a different level of generation. That's a peaking plant, or it's interconnector flows, or whatever it might happen to be. And the level of unpredictability of wind drives another layer of volatility in terms of the wholesale energy prices, and it makes it that much more difficult to smooth out those energy movements and to pass on a very set, transparent fixed price to a customer, which is what a customer wants in the long run. And I think the more we get, like, we're an island off the northwest coast of Europe, we have much better interconnection with the British market, and with the French interconnector we'll have with the European market than we would have had years and years ago. But the level of intermittent generation coming into the system, is happening at the same time. So it is a much more difficult process. And my own view will be that we will be getting into positions where demand side response will be of equal relevance as generation response in the market as well. And I think there's opportunities, for data centers in that space as well. Data centers will largely have, their on-site generation of the backup capability. And I think Liam and Lisa made the comment here, the signals need to be there as well. So, when you're looking at things like, fast frequency response or primary reserve, for data centers or any other large energy user with the capability to do that, to reduce their demand by supplying it themselves, for example, there has to be signals for them to do that. So I think, that's probably more the direction we're going to go in as well as we go forward. And we'll see much more complex products coming through the suppliers in the industry and making those offers out to the energy users, particularly large energy users like data centers.
Okay, so how does this square then? Maybe Damien or somebody else might want to come in, but how does it square with, we're seeing the likes of Amazon and Facebook announcing kind of deals with wind farm operators. It's kind of difficult to see how it works out. Do you account for it at the end of the year? Are they national renewables, or are they just a global thing? I mean, does anybody have a view on how that's working?
Well, I'll start. I mean, again, do certain people hide behind fuel mix disclosures? I don't know. I kind of think that the world has changed a little bit. This last year has, it's been very, very, very interesting, difficult in some ways. But I don't think we're going to be able to roll back to where data centers and occupiers are able to divorce themselves from that. So, is it legitimate to go and buy a PPA? 200, 300 miles, 1,000 miles away from where you're actually consuming. Yeah, at the moment, that's still, I suppose, in the market, it's still considered okay. And I think it's really good that the large players such as Google and Facebook, I mean, they've taken over a gigawatt of wind and solar. I agree. I mean, Lisa made a point earlier about the data centers creating the business case for some of the renewable projects that are out there. I think that's absolutely true, but I do think that, as Dermot just mentioned, we now have to kind of step in and do it more. Look, we see ourselves as an infrastructure provider, so that's the data center. It means some of the connectivity as well, actually putting duct in the ground. We have our own, obviously, we're building with ESB and with EirGrid, we're building substations. I think what we'll find is that there will be pressure from people to do a little bit more. So you're going to look at, just less than a week ago, Microsoft released a thing called their circular centers. So essentially, they're looking at ways to reduce their carbon footprint, get it to negative by 2030. They want to take 90% of the hardware that they use inside a data center and repurpose it, reuse it. And I think that's going to become the norm. If these data centers, and they are consuming more power and getting larger, they're going to be more campus driven. I think you're going to have to see renewables in there. You're going to have to see. We talked about regionalisation being closer to where your power is coming from. So to your wind farms or to your solar, you're going to look at on-site generation. You're going to look at new technologies, and you're going to look at trying to make these things as efficient as possible, from reusing your servers or the components, and possibly looking at other ways to streamline powertrains and things like that.
Okay. So this idea.
Sorry, David, I wonder if I could just come in on that particular point there. I think kind of Jamie made a very good point here in terms of when you match up kind of your, say, as an energy customer, kind of your renewable consumption of PPAs. I think you need to keep in mind this is part of an integrated system. So kind of an integrated system, the Irish system is connected to the British system, it's connected to the European system, etc. You can't physically track, an electron from a wind farm or, a power station all the way to the motor that's consuming it. So it's impossible to say that kind of every bit of energy I will consume comes from a very particular source of generation. The generation mix is from everything. It's from wind, it's from hydro, it's from, coal, peat, gas, etc. So you can't physically say, at one hand, this is where all of this power comes from. You have to accept that it comes from a pool of generation sources, but the mechanism that's in place for supporting the renewable generations in the system is through things like guarantees of origin, and you mentioned fuel mix disclosures yourself, Damon. So you can't link one to the other. So I think kind of when you're out in the market and, an energy customer is greening their supply, they're doing it through a number of mechanisms. They're doing it through guarantees of origin. They're doing it through corporate PPAs, and they're all very valid. They're very valid ways of doing it. But I don't think it's intended to say, my physical power comes from that physical asset, because you physically can't do that. It's just not possible to do that.
Should guarantees of origin be kind of local? Because I know in Ireland we probably import virtual renewable electricity in terms of guarantees of origin than we produce. It's not quite 50, it's 60.
Yeah, we're part of the European system. So when you look at yourself as part of a European system, you can't say, well, I will only, honour, Irish guarantees of origin, and I'll pay no attention to, kind of French or German or whatever. It's a European system. Spanish schools are equally valid, as Irish schools. And, if you look at it kind of at a level, that makes perfect sense, because, kind of we're all interconnected. So it doesn't really matter kind of where you buy the goods, so long as the money you're paying for that guarantee of origin is working its way back into investment in a renewable somewhere on the system, that makes perfect sense. Okay. But there's a perception that if you added up all of the the kind of the renewable contracts, or the fuel mix disclosures of all of the suppliers in the Irish market, it doesn't match the generation in the Irish system. There's a mismatch between the two of them, but you have to look at, we're not an isolated system, we're connected to, as I say, the British system and the European system as well, and that's where the aggregation should be looked at.
So Lisa, you're actually in France, and I know France is like 80% nuclear. Is that
nuclear?
Are we buying guarantees of origin from nuclear power plants to virtually power our data centers in Ireland? Do you have any?
I don't think we are. I don't think you're allowed to buy nuclear if you're claiming to be buying renewable. But look, I mean, you can see this from different perspectives. My own kind of, as an environmental economist, I kind of think climate change is definitely a global thing, and it really doesn't matter where that renewable electricity is coming from. The only thing, I suppose, is like we have all these different overlying kind of policy obligations. So within Europe, we have the emissions trading scheme. So, the electricity produced in Ireland, and in terms of our carbon emissions, doesn't count to Ireland. It counts under the European electricity emissions cap, which under the emissions trading scheme. So in a way, the Irish government, when they're trying to look at their carbon obligations, electricity is a little bit outside that. They're more concerned with the non-emissions trading scheme. In saying that, we have a renewable energy obligation, a commitment, a different directive. So if we're buying all our renewables from foreign sources with guarantees of origin, then we will struggle probably to meet our renewable energy directive target, which is it was 40% for 2020, for example. So it is a bit complex in terms of all these different policy things that are national, European, and then the planet, if you will. And you need to kind of consider them. And obviously the data centers as well, they're operating at a global level too. So they're probably looking at their fuel mix, not just in Ireland, but right across the board. But I would say as a starting point, it makes sense if you could try and generate your electricity locally from renewable electricity in Ireland. At least then it'll count for the Irish obligation and then the European electricity emissions cap. That'll be the starting point. But better than nothing if it's coming from elsewhere, I would say.
Yeah, okay. Because the ETS thing, I don't like to bring it up too often, but it's a very good point you make. There was an article in the press last week that said these data centers are going to cause us to miss our emissions targets. But if all the power coming from power stations or even generated on site in a data center is ETS, then it doesn't actually have any. Okay, we all live in the same world, so there's that. In terms of the particular article said something about targets being missed and fines, but they don't seem to be. It seems to be a mistake, and it's a common mistake that we see.
Yeah, I think it's understandable in that, as I say, it is quite complex. But my understanding is, emissions from electricity, that's not a target as such. But maybe they're referring to our, I don't know, other electricity or other emissions that are related to it. I mean, there will be indirect emissions through the construction of them. And we've seen that in the past, that our construction emissions and transport emissions go up as soon as you start building infrastructure. Maybe that'll be indirectly affected, but not usually from the electricity. Okay. Correct me if I'm wrong, somebody else. But
that's pretty good insight. I just want to move on back to this whole idea of flexibility. So if we have all this renewable energy in Ireland, we want to absorb it into data centres. There's this whole flexibility thing. I know, Liam, that EirGrid have a Flex Connect access policy. There's a consultation open at the moment, so anybody who's interested can go in and contribute to that consultation around the data centre connection policy. Could you explain to us a little bit about what that is?
Yeah, so in essence, like what we're really trying to do is that we're very aware that data centers are probably building quicker than what we can build the infrastructure to get the power to those demand locations. So what we're now trying to do is say, and we believe this may become a challenge or an issue for us from about 2025 onward. Is where we see this becoming an issue. So what we're actually really saying is that, well, can the large energy users start to help us through this transition, and we collaborate together to get to a better answer, knowing that we'll come through it later on in the decade. And really what we're looking at now is saying, well, we know that a lot of large energy users have their own backup supply on site, and therefore it's what level of that backup generation is there and how it can be utilized on the system. So what we're really saying is that if somebody actually has and we've always, like from an EirGrid perspective, we've been very clear that we believe that gas will be the supporting transition medium for getting from the 40% renewables to the 70% renewables through that transition. And therefore, if data centers are actually putting on-site generation to increase their more than what we can actually supply to them from the transmission system, then what we're supportive is saying, well, please install those generators on site, knowing that it's for a period in time while we work our way through it. Okay. And then once we get through this transition, these on-site generators, as Dermot has actually said, can provide other services into the overall system into the future. So, for example, if there's days where wind is not blowing on the island, or if it's not meeting the demand we actually have, these flexible generators, if they're high efficiency, could actually start contributing to what we actually need. And really what we're saying to try and work our way through the challenges that we have is that we're saying to the large energy users, in particular data centers, that if we can't meet your supply at time, and if the system is under stress, we will dispatch you down. We will constrain you back down to say this is the amount that you can actually use on the system. So it's trying to come up with a practical solution while we're trying to build infrastructure. And as we know, infrastructure can take any place between 7 to 10 years to build, whereas a data center might be on a much shorter time frame than that. So the theory of the consultation, we issued this a number of years ago, and now we've listened to the industry. We've gone out again with consultation to see this is what we're changing, and in essence, it's to get the feedback from the industry around the consultation and see if there's areas where we might need to tweak or change to allow us to meet the renewables target, have a secure system, and meet the as best we can the needs of the large energy users.
Okay. Damien, is this a re-engineering of a whole data center topology, or is it doable? Is it easy?
No.
Is it?
Look, data centers, the design, the kit that's used, the M&E, it's constantly in flux. Everyone is looking at ways to make it more efficient or to work better. I mean, and again, this isn't in any way we're sometimes I think there's a sense that there's an antagonism between the DSO and TSO and the data center, and it simply isn't there, because we have to work hand in glove to sort this out. I mean, in the policy discussions, and where firm power can be matched if you're generating on site. I mean, it's up to the data center industry to look at ways to mitigate flexible demand. There's no getting away from it if that's what's going to happen in the network. Okay, well then we need to work together to look at solutions. So I mean, we're looking at on-site generation. I know we'll talk about that a little further, so I'll move on. But we're also looking at large-scale battery storage. So I think the solutions where we can provide aid or assistance to the grid, it helps us as well. I mean, it's one system. We need to be able to help out on peaking. We need to be able to help out on frequency response. We need to find ways to make the data centers more efficient. We also want to get rid of diesel generators out of data centers as well. I mean, so everyone is we're all working in the same direction and looking at how our powertrain interacts with transmission systems, how they can support each other. But I certainly think the likes of batteries are going to come into it. We'll talk more about technologies, but fuel cells, etc., are going to come in. So, yeah.
Okay, that's doable. Dermot, is it just an evolution of the concepts I've heard you speak of, where we plug in our electric vehicle at night and it only charges if it's windy, and unless we definitely have told an app that we need it? I mean, are these things actually going to happen? Are these realistic?
No, they will happen. I mean, if you take the EV one, well, it's about what are the requirements, the primary requirements versus secondary requirements. So if you take kind of an electric vehicle and you're charging it, you're probably in bed from 11 o'clock till 7 o'clock the next morning. You don't really care whether the car is charging at 2 o'clock or 4 o'clock or 5 o'clock. You don't really care at all. So long as when you wake up in the morning, you have a full battery, full of capacity, you can drive it away. So, there's a different level of demand for an EV, for example. And I think the technology will drive, in terms of EV charging. It will happen overnight. That's when we won't be using our cars. And it will work its way through, and it will turn on and it will turn off in relation to all sorts of signals, renewable energy signals, price signals, etc. You look at things, and then if you look at something like, say, a data center or a pharmaceutical plant, they don't have that same flexibility as to when they consume or don't consume. You couldn't have a data center saying, well, I'll switch off now and I'll come back on when there's more renewables on the system. It just doesn't work. So you have a different dynamic for that. And that's where you move into spaces like, Lee mentioned, kind of, ancillary services, for example, and what can things like data centers do to support the grid, particularly over this transition period. And that's where I think kind of, Electric Ireland, where I'm working at the moment, we were traditionally an energy supplier. We very much see ourselves more as an energy partner now. So, the supply business used to be, we'll interface between the customer and the wholesale energy markets. We'll create a tariff and we'll send out the bills and we collect the money and we'll distribute that money to EirGrid or to ESB networks or to wherever I want to go. Now, actually, kind of, the supplier business is moving much more to an energy partner type arrangement where you're not just providing a billing type functionality, but you're providing advice and guidance as well. The energy business is our business. We understand, say, the ISM market. So Lisa mentioned the ISM market there. the ISA market is a very, very complex market. There's numerous forward markets, there's day ahead markets, intraday markets, etc., etc., etc. There's no way in the world you could expect a customer to understand all of that. That's our business. So it's our business, I think, to interpret what are the commercial levers that are on offer and to work with customers, for them to get the best results that they need. So flexibility has various varieties, I suppose, where I'm coming to. You have flexibility on just pure energy demand, like your EVs, switch on, switch off when you're going to get it. And then you have flexibility in terms of what services you can extract out of the market in terms of ancillary services, for example. So if you're in a position to reduce your demand behind the meter in response to some, grid signal, for example, and you can get paid for that, then, if the economics match up for that, you'll put yourself in a position where you can do that. So I think there's various varieties of this, but without a doubt, we're moving into a market where, flexibility is going to be king, both on the demand side as well as it's always been king on the generation side, and now I think it's going to be king on the demand side as well.
Okay, so maybe a question for Lisa, maybe. So we obviously with wind farms, they're kind of curtailed or constrained off when it's in certain conditions, because we haven't quite reached that 95% that Liam talked about. How much flexibility is needed to allow us to use all the wind that's available, or is there some equation where we know, flexibility gives us a certain amount of reduction in curtailment or something like that? Is that something you guys have looked at?
Well, we've looked at the overall power system for 2030, and we have a project ongoing called Empower that also provides advice to the government department. And my colleagues in really the power system engineers, so that'd be Rena Leon and Damien Flynn and Sarah Stanley, they've been modelling using this model backbone. So it's not just about data centres, it's about modelling the technical requirements of the power system with 70% average renewable electricity in 2030. And of course, data centres play a big role in that. I agree with Damien there that we need to look at looking at how we can use demand to provide this flexibility, so storage and flexibility and other system services. And so the things that we started looking at are data centres and how that can help with price peaks and spikes and also curtailment. And what we'd love to work more closely with the data centres, just because what's difficult for us to understand is exactly what is the capability of data centres to provide this flexibility. So right now we're modelling different scenarios of 10% load flexibility, 20% load flexibility, 30% load flexibility, and we'd really like to understand better over each hour of the day what is the most likely to happen. But just using those scenarios, we do find that if you have our model would show, and really it's early days of this kind of modelling, that in 2030 where you might have about 9%, 10% curtailment of wind, that if you had 30% flexibility, load flexibility from data centres, you would reduce that curtailment a little bit, but it doesn't amount to, it depends what perspective you're looking at this from, but you're talking about just under 1% reduction in curtailment if you had that level of data centre flexibility, which I imagine is a large amount of data centre flexibility. And my colleagues then on the distribution side, so Ali Reza and Abbas, they're looking at more from a distribution level, also EVs again and heat pumps. So it's not just data centres, there's a lot of moving parts in this, but we definitely think that that this kind of load shifting, if it were possible for data centres, it would do a lot, both in times of high demand to reduce it down, but also those times that we have, we run a lot of different scenarios. A day that's very windy, for example, where the price drops to near zero practically. If data centres could be using more of that load on those days, that would also. So we're talking about prices that go up to 150 euros a megawatt hour without any flexibility, but that a data centre kind of operating in a flexible way could maybe smooth it a lot more so that you could stick around 90. But we're still working out these models. We'd love to work more closely with the people in the industry to see how realistic and practical many of these are.
Okay. So there's a lot of moving parts there. It's
really are, yeah.
Liam, your thoughts?
Yeah, no, I agree with Lisa. I think one of the key things for us is that, and we're very clear on this, is that we can no longer just rely on the generation to give us the flexibility that we actually need. All aspects of it has to be an active player in relation to the flexibilities that we need into the future to be really successful in the transition that we're actually that we've undertaken. And for me around this is going that it's even some of the flexibility that Lisa actually talked about, that if we could, manage that instead of actually having a generator on the system or conventional generator on the system carrying reserves, that if you had a data center or large energy user that could shift its demand from one location to maybe another location, you now have almost replication of virtual interconnector, and it's also allowing for extra flexibility. And I don't know if any of that's possible, but they are the items that I think we need to start exploring, because there will be times like where we have low wind, as Lisa has actually said, and in those occasions we will have to find other alternative types of generation to meet that demand, whether it's batteries, whether it's storage, whether it's interconnectors, or whether it's demand reduction during those periods in time, or conventional generators, or some of the future technologies that may actually give us those cleaner energy services that we actually need. So all of that in the mix when we're actually thinking about the solutions that we need to actually come up with. And I think in relation to the curtailment element, there will be times like where we have more supply of renewables on the system, because if all the wind is producing at the same time, we may not be able to consume it all. So the battery and storage is really important in relation to those aspects, but also some of the demand shifting is really important. So we are doing a lot of investigation and work around that to come up with a pathway to 2030, which covers the market, the operational flexibility that we actually need, and also the infrastructure, the minimum infrastructure that we will need to build to allow us to meet the demand growth that we expect, but also the renewables targets that we need in both jurisdictions.
Okay. Great. So I suppose we were going to talk about on-site generation, but I think we've kind of covered this piece. Unless Damien, you want to chip in anything else?
Given what's just been said, and I agree with pretty much everything that's been said there. I know from our point of view, we look at this as it's now incumbent upon us to look at on-site generation. Again, the plan is that if we're using gas, we try and make it as renewable as possible. That's unfortunately we don't have enough renewable gas yet to do that. So again, you look at technologies into the future. You look at hydrogen generation. That we'll talk about that, I think, a little further. But
we can talk about it. We can talk about
it.
Well, okay. This idea is quite interesting.
You look at another example, and I've used Microsoft a bit as an example. They've put $1 billion into a fund to look at what they can do to push things along, make things greener. And they've recently run, I think, a data haul on fuel cells, hydrogen fuel cells. Now, I think commercially we're probably still 2, maybe 3 years away from, say, us being able to get hydrogen fuel cells to go on site. However, it's certainly part of our thinking that we can look at on-site generation. You can look at on-site generation from gas, which will be used to support the grid. The grid will support us back with firm power. We'll try and keep our demand close to where the power is generated to not put pressure on backbones. We will then look at other technologies like battery for frequency response. We will also look at maybe changing the powertrain within the data center. So you'll probably look at kind of your on-site generation, your UPS, but then you'd have a shared resilience from the other things that you've put in place. So you might need to look at diesel generators. You might be able to move certain other things out of the linkages. Again, I think all of this is we can then look at hydrogen creation using the batteries for hydrolysis and things like that. There's a certain circularity to all of this that once you start thinking about it, once you start to invest in it, there are solutions there that can work for the whole industry, and to the benefit of the country.
So this hydrogen idea is to take all this surplus wind, particularly maybe offshore wind, use hydrolysis to turn that electricity into hydrogen, store it, pump it into the gas grid, use it in your on-site generators, or
use it in your fuel cells.
Your fuel cells.
I mean, if you use the fuel cell, the output, generally, if you're using a hydrogen fuel cell, the output's going to be water, and then so you use your hydrolysis then to get your hydrogen to go back in, fuel the data center.
Okay, so that's your 100% green option for gas, really, if you have the gas generators. Is it in the lifetime of your the generators that you'll build next year, for instance? Will this solution exist before you have to bin those and buy a new set? I mean, is this hydrogen thing 20 years away, or is it 5 years away? I mean,
the fuel cells aren't new technology. This is a new application of the technology that exists. In terms of, and I think everyone has kind of mentioned this already, you have to be pragmatic. You're not going to throw out all your old infrastructure and go, okay, we haven't immediately said, okay, let's just plug in wind energy, because you have to balance out the effects of these things. So again, what I will say is certainly it's very prevalent in the data center industry that all of the design is now leading towards more sustainability, more renewable energy, trying to see if we can do more reuse and recycle the kit that's used in data centers. So it's not perfect yet, but certainly we're pushing that way, and there's more work to be done.
Excellent. Okay, so maybe we'll just have a little. I know we're going about 10 minutes over where I wanted to be for the Q&A, but I'm enjoying the discussion. So I think before we go to the Q&A, we'll just throw in a few more questions. Lisa, we talked about the climate action plan and the climate mitigation plan, and needing some change. Do you think there's anything? I mean, if you put your future gazing hat on, given what you've learned in the past 60, 70 minutes about data centers, are there things you would wave your magic wand and say, well, we should do this or that? I don't mean to put you under huge pressure at 70 minutes of a primer.
There you go. Well, I think what we realized is that just with regard to data centers, that they're not going to be a silver bullet in somehow solving, the flexibility issue for renewable electricity. I think that's kind of at the outset. I think what's interesting is to look at what's going to happen to our whole climate policy in Ireland. The climate policy, so in July 2020, now the Supreme Court has thrown out the National Mitigation Plan. That was a case that was taken by Friends of the Earth, who said that it wasn't compliant with, I think it's a European directive that required us, we had a national legislation requiring us to give specific details on how we were going to reduce our carbon emissions to 2050. So the National Mitigation Plan has been quashed, but I'm not exactly sure where that leaves our Climate Action Plan. And I think our Climate Action Plan did give enough detail to get, if we implemented every measure of the 183 of it, it would actually deliver the targets for 2030. So that was one of the first plans that ever actually included everything that it needed. Now, it's still very difficult to implement it. So, our jobs certainly are not over. If we tried to have 1 million EVs by 2030, I think that number alone kind of sends a shiver down every policymaker's spine, because it just seems so far off. But we still have a 2050 after that. So there may be some more policy making will need to be done to see the longer term view. And I think with regard to electricity, the longer term view is definitely going to be offshore wind on the west coast, which we haven't talked too much about here. But that could be, I think that if it comes to pass, again, I'm not a power system engineer, is going to be a game changer in terms of the electricity that's generated, the infrastructure required, where it's going to, who's going to buy all this electricity. I mean, the quantities are staggering of the potential that's there, and how that will affect the whole data center industry as well. So for me, that's the kind of the big thing. And hydrogen, I think we touched on it there in the last discussion, is could be a game changer. Hydrogen right now is extremely expensive to produce. We have some PhD students in UCD working on this just for their PhDs. And you can see that even assuming all your electricity used to make the hydrogen comes from excess wind, in other words, zero cost electricity, it still is not competitive really on the market right now. But there's no doubt that that's something that's going to change. And with the quantities of offshore wind that we're talking about for the future and the data centers, I think that hydrogen will definitely play a big role in this. So I'm putting that out there for the next to talk about further.
Okay. Liam?
I agree with Lisa. I think like from us when we're looking out to 2050, we're in the North Sea, which is the west coast of Ireland in particular, the amount of renewables that we see, the potential of connecting there. Really what we're seeing is how we effectively can get that onto the Irish system. So it keeps us very competitive around the price of energy. And then at the same time having the proper connections to the rest of Europe so that we're supporting the European targets as well, but also making sure that the revenues that can possibly come back to the Irish state from the selling that energy off the island is really important as well from our own competitiveness. And I know that the department has been doing a lot of work and a lot of thinking around that area. And I agree with Lisa that from what we believe is that hydrogen might become cost competitive around the 2030 time horizon is based on what we're seeing at this point in time. And we have an opportunity to start looking at what our gas network should start looking like. So potentially having the hydrogen production over utilising that to move it across Ireland and maybe over onto Europe as well. So you have both the electrical interconnection and you also actually have the gas network and been utilising those more effectively. But some of that will take time, and I think you're probably looking at that being post 2030 is becoming the real benefits of those.
Okay. There's a concept I've come across where if we look at the value of the data, so if we say like Ireland exports, like I think it's 70 or 8 billion worth of ICT services. But if you compare that to the energy market that's related to data centers, there's a multiplier of a few hundred to one in terms of the value of the photon being a few hundred times the value of the electron. It's just an interesting concept, the idea that should we be building interconnectors to shift electricity off or hydrogen or whatever, or should we be trying to use it here and take advantage of the big demand data center customers that we have who are converting those electrons into high value photons and sending them through a cable that's the size of a hair. Just a concept, just an idea I've come across a few times, and it's incubating there at the moment. I'm not quite sure where it's going to go, but Dermot, our resident meteorologist, is going to tell us the answer.
Well, just to comment on that, I think kind of where we are is we've two policy decisions that we're trying to align. So, the high-tech industry and technology in general has been, a real driver of our economic growth over the last 20 years and probably and hopefully likely to be over the next number of decades as well. And data centers are part there, they're one side of the same coin in relation to that. So I think we need to look at, how do you accommodate that and align that with the other policy decision that we have, which is decarbonisation of our economy. And decarbonisation of our economy at the moment is driven by, largely it's wind at the moment. The topography of Ireland is such that we don't have, huge hydro assets. I don't think we'll ever see large-scale nuclear in this country or small-scale nuclear for that effect. So we're trying to align these two policy decisions. And what you're looking at there is how do you align them? And there's a number of options to do that. Basically the real fundamentals here, the wind will blow when the wind blows, and when it's not blowing, you can't expect energy demand to drop. And when it blows too much, you can't expect energy demand to ramp up quickly enough to meet that. So you're looking at what are the options around that. And it is things like storage, storage through batteries. it's storage through hydrogen, and hydrolysis. It's interconnection. So if you can't find the demand on this island, can you export that demand somewhere else, to GB or to France or whatever? And you're looking at kind of other storage, like it's back in the 60s, we took the top off the mountain down in Turlock Hill and we built a big pump storage capacity. Now, Liam, you probably have a better view on this, but I would imagine it will be extremely difficult to manage the system without pump storage being within it. But pump storage gives you that kind of capability to store extra demand at scale in a system and then release it kind of when the wind isn't blowing. So when you look at kind of, what we're trying to do here, we're trying to manage the decarbonisation of the industry largely through intermittent generation sources. And we're also trying to keep going kind of a very successful industry for this company for the overall economic growth. And I don't think there's no one answer. So it's not that we would just export and that's the answer, or it would be small scale storage and that's the answer, or it's EVs and they're the answer. Or it's pump storage. It's all of these together, and it's things like, ancillary services. And, 30 years ago, there was maybe a half a dozen, players in the market. There was the generators, the grid operators, and customers really didn't have a choice. They took energy. They were a single tariff, and that was it. They had no incentivization. Smart metering is going in now. So all of the larger industrial customers can check their energy usage on a quarter-hour by quarter-hour basis. That's moving its way through the small, medium enterprises and through the residential. So the market will become a market of several million players, each of which will be able to influence in varying degrees the energy demand and the energy balance in the system at any one point in time. So I suppose what I'm trying to get to, there's no one solution. It's not that this is the answer. It's a combination of things that are going to deliver this for us. And I said at the start, we've overcome huge challenges in the past, rural electrification, Ardent Croatia, all of these things. And this is just another step on the way. And I have absolutely no doubt we'll be able to do this one as well. But every segment will have a part to play in this.
Excellent. Damien, more smart meters, that bolsters your business model. That's lots of data coming through.
I mean, again, when you mentioned about electrons versus photons, I might as well bring gravity into it as well. There is considered at a certain point a certain gravity to this data. When you get so much of it it's like a black hole. It becomes almost impossible to move. And given our country has done so well in terms of becoming a digital and a data economy, we're actually very well positioned from a European point of view to actually say that all of the data centers that are here, all of the gravity of all that data that's here, it will get to a point where this is embedded in our economy, and it won't go anywhere because it'll actually become impossible to move. So I think this is good that we're looking towards the future and to deal with this, because I don't think it's going to go anywhere. I think the demand will just rise. Okay,
cool, excellent. I think that brings to the end our discussion, but I'll jump on to the quick fire round for about 10 minutes, which is the Q&A. So I'm just going to read through. I see a few here, so I'll just flip through them and we'll give you a chance to I'll throw them at somebody. So first question, John O'Connor, just a question in relation to development of edge data centres in Ireland. How do the panel see this area of development in Ireland? Damien, that's probably for you.
Edge, well, okay, so again, this depends on use. If we look at 5G, if we look at various services that need to be cached and you need to be closer to where the data is going to be consumed, you will have requirements there. I would imagine that they'll be relatively small. When you get to kind of autonomous driving, that's the real one where you will almost need the cars to work as small edge data centers and transfer around communal information. A lot of that is driven by latency. So again, centres like Dublin, we have more than enough infrastructure. Any of the cities in Ireland would have mostly the infrastructure that's required. But what happens if you're driving down a boreen in I don't know, at Kildare where I live, and suddenly you're out of coverage or you're not within a 1 millisecond latency of the nearest edge? There are questions still. I'm not sure anyone has the answers on how densely these are going to be rolled out there. But I certainly see regionalisation as helping. it certainly won't hinder. And then who's going to pay for it? Who's going to do it? Are other really big questions. Is it going to be the mobile operators? Or is it going to be the likes of the grid? I don't know.
Okay, could be a huge edge discussion, edge and fog and such things. Darren Smith, would they consider an off-grid solution from renewable sources other than reliance on wind, which is unpredictable? I'm not sure if this refers to on-site renewable generation, off-grid solution. Anybody else talk about Liam?
Yeah, so we're open to all types of renewable generation coming onto the system, and we think all can actually contribute and help. Like we see at the moment, the main part has been wind, but like solar has in recent auctions have started to connect or looking to connect onto the system, and even looking at some of the future likes of hydrogen and burning hydrogen for fuel sources. We see all those can contribute to what we actually need. So we believe there's no one solution, but at the moment we see wind as being the main renewables coming through.
Excellent. Okay. Next one from Paul Boylan, Vivid Edge. Switching to renewables makes sense. However, energy efficiency and optimization should always be a prerequisite before any investment in renewables, particularly for established or legacy data centers. Seeing a drop in energy efficiency projects due to the pandemic. For some, efficiency is being classified as non-essential spend at a time when it should be considered more critical than ever. I would like the panel's thoughts on this, and are they still seeing barriers to energy efficiency, example capital, other priorities, insufficient payback, etc.? Nice essay, Paul. Lisa?
I'll take that, yeah.
Yeah.
Energy efficiency, I know, I was thinking I had just gone through a webinar without mentioning energy efficiency, because it's close to my heart in terms of policy. There you go. So now, thank you for the question. I totally agree that, I mean, today we've really focused on electricity, but energy efficiency is extremely important. Partly, I suppose, in the non-electricity energy sectors, particularly like heat, transport, ones where it's going to be very, very difficult to increase our share of renewables. But yeah, I like to quote the IA, my old employer, energy efficiency is the first fuel. And if you look at the costs of generating compared with the cost of every kilowatt hour you save, it makes sense to reduce your energy use first. I think it's going to stay in a very strong way on the policy agenda, because we have a European target for that as well. And I think in the residential sector, there's kind of a two-pronged approach with this introduction of heat pumps and EVs. But if you look at any of the grants now that are going to be available, the heat pumps will come with renovation of the building. You won't be allowed to just put in a heat pump and leave your building as a G-rated building. So I think that it doesn't make sense really to do one without the other. Usually you have to put in underfloor heating if you're putting in a heat pump. We're getting away from data centers now, but just in general, I think you can see there's a lot more schemes now for businesses as well in terms of energy efficiency. The Exceed scheme with SCAI and small SME schemes. There are still a lot of barriers, and energy efficiency finance remains a problem in terms of access to finance and getting it out there. But I think these are all policy questions that will get a big push over the next few years.
Very good, very good. Next one up from Emma Fryer, Tech UK. Emma, really interested in discussion about PPAs in the UK. Tech UK or UK organisation, obviously. Large developers are paying for substations, and the big cloud companies are doing PPAs, generally indirect. I'm aware we have a different operator profile in the UK, and we're trying to explore how we might aggregate demand from PPAs and de-risk the process. Has anyone thoughts on that?
Well, just maybe from a commercial point of view, historically there were more smaller DCs in the UK, certainly around London, a lot of old carrier ones, and multi-tenanted data centres, so not just one occupier. So we've seen in Ireland, obviously, we've got a lot more of the hyperscalers and large campuses. So it kind of affects your ability to look at PPAs. The larger guys are certainly going to be committed to it. They've all openly stated how committed they are to renewable energy, green energy, and are putting money behind it, which is great. So it's a kind of a slightly different landscape that's being played in the UK, where they're only now starting to get the really much larger sites. So I think it'll be ongoing. And again, what we discussed earlier about, regionalisation and maybe, things moving out of London, maybe up towards Manchester, Newcastle, places. You will probably see certainly some larger sites, some campus sites where people can look at on-site generation, or they can look at, bringing renewables closer to the data center, and then hopefully more local PPAs rather than, maybe what's being alluded to.
Okay.
Yeah, I think just add to that. I think kind of what we're seeing in the market is there's an appetite for PPAs, corporate PPAs in particular. But I think like anything else in the market, kind of you have a cost benefit kind of analysis to do in relation to that. There's a willingness at which, a corporate is willing to hit a strike price that's attractive to a generator for a corporate PPA. And it's a price at which they're not. So, I think kind of it's there, but you can't move away from kind of the underlying commercial realities. People need to run their businesses as commercial enterprises. And while there may be CSO requirements, to greener supply, corporate PPAs is one way to do it, but it's not the only way of doing it. So there are other options of doing it as well that don't carry maybe some of the commercial aspects of corporate PPAs. So I think there's a demand in there. But that demand will always be, enhanced or mitigated depending on what the strike price for the corporate PPA is.
Okay. It's an economic thing. Simon Leonard, something about hydrogen fuel cells. I think we kind of covered that, Simon, so hopefully you're happy with that. Dermot Brady, battery storage for resilience, periodic grid stabilization. Again, I think we've kind of touched on battery use. Emma Furr, Tech UK again, slapping my wrist about the ETS. Sounds like a red herring to me, Dave. ETS only covers scope 1. Good point. Emma will take that. Ronan Nevin, the new data center connection offer process has made dispatchable on-site generation more relevant for data centers. Should the PSO paid by large users be changed from being charged based on MIC to a grid consumption-based charge? It's kind of an interesting one. Should you be paying on capacity or paying on energy consumption? Liam, maybe you have some thoughts on that?
Yeah, I think one of the things around this is that, and I touched on it earlier, is that we have a lot of large energy users which have said they need more capacity than what they're actually using. So therefore, it makes it difficult for us to build the network. So if we can get more clearer picture around what the current capacity needs are and the growth, it allows us to utilize that more effectively. But it is something that we are engaging with. So we started some work with the CRU just in relation to the future tariffs. So, and I expect that the CRU will be consulting about future tariffs in the not too distant future.
Okay, some great questions here. Another one here for John Booth, disagrees with using backup fuel cells and hydrogen as a backup, and they should be primary power. Interesting point. The nature of fuel cells means minimal UPS requirements. As the array effectively acts as a UPS. Interesting. We need to discuss it. What's the point? Kieran Ford, Eaton have been long-standing advocates for data center supporting the grid with services that accelerate the adoption of renewables. A few DC connected data centers connected in the Nordics, and looking forward to the first one for Ireland soon. The UPS is key in this regard. I think he's referring to the UPS systems they supply, and maybe others have the capability to provide two-way communication with the grid and provide fast frequency response and battery backup. Another expert in this area, and he's also from Eton, Jane Panan, fuel cell weakness is the dynamic response to sudden large load changes. These do not normally happen within a DC, but in case of fault conditions, could be. Reliable design based on fuel cells would incorporate some battery storage in the UPS. That could also provide fast frequency response for the grid to protect against contingency events. So this idea that your UPS system could help make the grid more resilient, Liam.
Yeah, and we'd be open to all technologies coming on, and again, that the system services model that we're looking at producing after 2030, we'll look at different services that we need, and if those technologies can provide, we will be running auctions or markets around those to make sure that we get those services in and people can provide those services, which is really where we need to be going.
Okay.
I think there's just one point in relation to hydrogen is worth noting. So if we're looking at hydrogen as an on-site primary generation capability, I think you need to look beyond just kind of the actual, generation, distribution requirements for hydrogen as well. So, we don't have a network in place at the moment which can distribute hydrogen all over the country. So really what you'd be saying in that particular instance will be you'll be generating all your hydrogen that you would need for your generation requirements on site. And I'm not sure of the feasibility of that. So I think hydrogen is great. I think it's part of a solution. But I'm not sure. I mean, it looked at the same thing, the hydrogen fuel cell versus EVs when, the battle was taking place between is it going to be hydrogen cars or electric vehicles? And one of the driving factors, excuse the pun, in relation to that, there was already an electricity infrastructure in place. Electricity could be driven and could be sent to the end demand point. That's not the same for hydrogen. We don't have a network which supports the wide-scale distribution of hydrogen.
Okay, interesting. So, yeah, okay. Damien Dalton, since the average PUE at 1.6 uptime survey 2020 hasn't really changed in 7 years, is the industry serious about efficiency? I'm not sure I agree with that survey or what it actually captures, but Damien, maybe you could comment.
Again, I think you'll find that most of the larger data centers now are looking at 1.15 in terms of PUE, and we can argue whether it's really a good measure in the first place, but that's for a different day.
It's a different day.
But I would say that certainly any of the larger sites that we're looking at, the infrastructure we're looking at, you would be looking at a lot lower than 1.6. Certainly.
Yeah, I would concur with that.
Maybe legacy sites, perhaps, yeah.
Okay, I've just two more. Matthias Bayer, do you see carbon offset projects, reforestation example, as a considerable temporary option in the green transition, or maybe even a long-term option to become carbon negative? Reforestation, maybe Lisa, you might have some views on carbon offset?
Yeah, well, I mean, it's part of the climate action plan, basically, where we weren't too hard on agriculture. It seems to mainly consist of planting a lot of forests, and there's definitely Ireland will use this as part of meeting our CO2 emissions targets, no doubt about it. And there's a lot to be done in afforestation in Ireland. We've been behind for a long time.
Okay, cool. Final question, Damien Dalton, will the green credentials of co-location providers become more important for clients in the future? I think that's a good one to end on. Co-location providers they take all comers really to sit their servers in their buildings. They're a bit smaller than behind them a little bit, and that the bank doesn't. You don't necessarily know that Equinix provides the link to the bank. Is that more important nowadays? Damien?
I think that's a very good question, and I think it's a very. I'm not sure I have an answer on that because of the mix of customers. By their nature, you can sometimes be left with stranded power, stranded space, or if one person comes in and needs a certain density of rack, it's a difficult thing to manage that. But I think certainly you will find that all of the larger players, your Digital Realties, Equinix, etc., they're all committed to renewables and sustainability as well. I'm very open about it. It's just a more difficult environment to do it than having a single occupant.
Excellent. Okay, so we're out of time. I might give you each a sentence. You can do a closing word if you like, and then I'll wrap up. Dermot, you look like you're itching to jump in with your
We must work on my face then.
Your poker face isn't great.
No, I just think it's been a really good panel session. I'd like to thank all my fellow panelists as well. I think it's been really, really informative, and I've really enjoyed it. I hope people got something out of it.
Liam?
Yeah, I would just agree with Dermot, and I would also say that for us into the future, collaboration is key, and that we need to keep talking these types of sessions to try and work to the final solution that we need.
Damien?
Again, I'm going to reiterate what guys have said. We have to work closely together, keep open dialogue, and collaborate very strongly, and try and have a more sustainable and renewable data center industry.
Perfect. Lisa, you get the last one.
Excellent. Well, I think it's exciting times in the energy system at the moment. There's no doubt the whole system is undergoing a huge change, and data centers are now becoming a bigger part of that. So we think, and we always call for this, as more research, I suppose, in understanding how these impacts are going to manifest themselves in the system. So we'd love to also collaborate with anyone who would like to work with us in UCD or other partners. Thanks.
Perfect. Listen, thank you so much, panelists. You've really been excellent. The discussion has been fantastic. It's over 90 minutes worth of it there. So thanks for that. And thanks to Hugh. I see him coming on here for setting up the session. And of course, thanks to the viewers for their interest and for the Q&A as well. Thank you very much, Hugh. I'll pass it back to you. We can't hear you. Sorry, Hugh. There you go.
Look at that, even I can't drive my driving is not very good. I wanted to say thank you to all of you. We've had some great comments in the chat room about the breadth and depth and the interest and the practical nature of what you've all been discussing. So I want to thank you on that. We shall be making this available as a download after the event. I want to apologise. There's been a few sound issues, but overall, I think it's been very interesting. And I want to say thank you to you all. So on behalf of Data Centres Ireland, thank you all very much, and I hope you have a cracking rest of the day. Take care.
Thank you.